All right. So here's a list that Harold, thank you, Harold, helped to kind of get together of some of the most important issues that we thought we would talk about. The first one might be, maybe we should get into blank notes, but actually before I do that, Harold or Emily or anybody else, is there, do you want to make any sort of general comments before we launch into this list or questions or anything?
Well, yeah, just background for some of the people here is that one of the primary goals on the FHIR RDF specification as exists today, and it's still one of our goals, is complete round trip ability, the ability to go from what we'll call as the FHIR logical model, the internal model, or what have you, to RDF, and to get from RDF back to the internal model without losing or I guess a weaker sense, gaining information. And we made some decisions in the original RDF that you know very much favored making round trip ability very easy. That one one of the primary ones is we made sure that FHIR says that you can extend Boolean if you want to. We made sure that it wouldn't be hard for somebody dealing with an extended Boolean to treat it the same way they treated an existing Boolean. The problem being is that it made treating every Boolean hard because we don't strictly have a Boolean type in the FHIR RDF. A Boolean is a structure that consists of a Boolean value and anything else you want to add to it. And as we've gone through trying to use this in Sparkle and other applications, what we've discovered is that there's a lot of places where we think we need to revisit and make it easy to do a Boolean and possible to do an extended Boolean, but not make Boolean hard in the process. And there's a number of things in here that directly or indirectly relate to that.
Good, thank you, Harold.
Yeah, and one of the questions I think we still need to address a little bit is that I found some of the stuff difficult when I tried to use it, but any changes to the specification are going to be both time consuming and costly. And so on the other side of the coin, we don't want to make gratuitous changes if there's no call for them. If people are happy with the status quo, then we should stick with it.
Thanks, Harold. Are there any other comments or questions that anybody wants to make before we get into some of these specific issues? Okay, so let's take up the first one here, which is issue 77, blank notes to support FHIR extensions, what Harold was just mentioning. So what I'm going to do here is go to that issue. It's on our issues list. And here's our issues list. I'm going to go right to that one. Okay. So the basic question is, okay. So when we designed the R4 version of FHIR RDF, as Harold mentioned, we used an extra level of blank nodes on primitive types and other, I guess primitive types, because I think they were already on other ones, in order to accommodate the ability to have extensions. So the basic question comes down to, well, if we don't want to do that in FHIR RDF R5 because it makes it cumbersome, what should we do instead? And I guess I need to show an example of what this looks like currently. So here's an example of what it looks like in standard FHIR JSON. So they have this convention when there's an extension that the name of the property gets an underscore in front of it. It's a syntactic convention. And that's where the extension is placed. So this allows you to attach anything else that you want on it. In this case, they've attached a URL and the URL I think identifies what kind of extension it is. And then the particular extension is this bit here, if I'm remembering correctly.
Yeah,
And correct me if I'm wrong, Harold. Yeah, go ahead.
note that the data type is actually encoded in the value
Oh, right. Yep.
in the label itself. So one
Yep.
one actually has to decompose that or to take the date time part of that label to get the data type of the thing in there.
Yep. Right. Yeah. Okay. So when that's when that's converted to into RDF, yeah, but I'm just wondering if we have the old example.
Okay, yeah. So scroll
Okay,
down.
here we
Yeah,
go.
right. So,
Yep.
oh, yeah, and matter of fact, that's it. That's the one we were looking at. You got it. 'Cause
Oh,
that was
good.
the
Okay.
extension, right?
Yep.
That's the same thing here. So,
Yep.
so what we've done is, and this is considered conformant with the FHIR XML specification. This is a transformation the way XML does it. Is instead of having the mangled name on birth date, one of the things the pre-processing things we have to do, we can't see that your box is over top.
Oh, yeah.
Yeah.
Yeah. I just
Okay,
wanted
one
to
of the
save
things
it.
we have to do is as we go through it, we find the underscore birth date and we fold it inside. So note that if we're dealing with extensions on non-data elements, so birth date is very specifically a date. If we were extending a complex structure, then it's no problem because it already is a nested node. It's just here that we've made birth date a B node where we have a FHIR value inside it. And then we put 0 or more extensions. And therein lies the rub, is that the vast majority of the time, there's going to be 0 extensions. So instead of just having birth date 1974-12-25, we have what you see over on the left-hand side, birth date with that, and then no extension. And so that makes extension processing simple, but it means that if you run a query, a Sparkle query or something to fetch the birth date, surprise, surprise, you get a B node rather than a date, and you have to dereference that B node and then go inside and to get the value, which he's got highlighted there, to get the actual date. And add to this the note that if you're doing Sparkle queries, you have to do that at the same time. You can't say, give me the value of birth date, and then run a second query saying, or give me the birth date and run a second query give me the value associated with the birth date, because one of the rules on Sparkle is that B nodes act as wildcards. So it makes Sparkle difficult. Your Sparkle queries always have to have, the chain from birth date to FHIR value.
Is that is that making sense to everybody? First of all,
yeah, I've actually had that experience when I've actually tried to write Sparkle against FHIR RDF. Yeah. It's really, I mean, it's one of those things that once you get used to it, it is what it is. But I agree that it would be ideal to not have to do that.
Yeah,
and it gets even harder when you start joining FHIR to other RDF. But yeah, I mean, we can get through it. And in fact, the gender up there is just a classic example of the line above what he's got highlighted there.
Oh yeah, there's a perfect example right there.
You say, give me the patient gender, you get a B node, and yeah, you learn, but that means that FHIR RDF out of the box isn't something that is intuitively obvious to somebody writing Sparkle queries. Where it should.
Yeah, so I think this denote problem is not unique for extension, right? So I think those denotes have been extensively used by FHIR. For example, those codable concept of coding.
Well, but the reason it shows up with such simple cases as these, like a data type property like gender or birth date, where you would normally expect the value of the property just to be right there. The reason it isn't in FHIR RDF R4 is because we wanted to enable extensibility as FHIR requires. So we were trying to be trying to follow that rule to enable everything to be extensible. And so we didn't figure out a better solution for it at the time other than to put that extra blank note there.
And noting that that the JSON implementation didn't follow their own rule, in that
yeah,
if one wants the extension to birth date in JSON, one has to actually have an intimate understanding that this is a separate tag.
Right, with an underscore.
And one other aspect of this, just to be aware of, because it comes into play periodically, is that FHIR makes a distinction quite correctly between what we'll call, I don't know the term they use, but non-modifier extensions. Extensions that add additional information to the thing being extended, but don't change its meaning. So a traditional FHIR extension like the one we've got here, which just adds granularity to the birth date. If you understand the birth date, you can get more precision, but you can continue to operate even if you don't understand what this particular extension is all about. It's just that you can't do anything with it. There's another class of extension, however, called modifier extensions. And that class of extension, modifying extensions be represented. And a modifying extension actually changed the meaning of the thing being extended. So, I mean, it's, if this were a modifier extension, we might have an extension that where the value was such and such a date, but then our extension would say not born on. So you know, we extend the birth date by saying we don't know what it is, but it wasn't 1974 12/25. That's something that's legitimate to do in FHIR, and you will find in cases. And in that case, the problem is if you don't understand the extension, the FHIR rule is that you can't process anything. I'm watching this go on here, David.
Oh, go ahead.
Yeah,
I'm just, go ahead.
Yeah, you can't
There's something
process.
to illustrate.
Yeah, you can't process the data element at all if it has a modifier extension. And this is where we've kind of, it's a strong philosophy in RDF. The notion of, I think the term is idempotent, the fact that you
Monotonicity.
Sorry, yeah, monotonicity. The fact that adding information doesn't change or negate existing information. And in FHIR, where oh right, and you've got that written up here. That's great. Yeah, good. As far as I know, correct me if I'm wrong, David, but in the FHIR JSON, if you have a modifier like on birth date, I don't remember. I think that instead of saying extension, it says modifier extension inside it.
I don't recall offhand.
The general notion being that in JSON, you're not really allowed to take 3 fields out of 10. So if you've got a birth date and an underscore birth date, the assumption is that your JSON includes that complete package. In RDF, however, since we've cut things up into bite-sized chunks, there's no guarantee at all that if you do a Sparkle query, I mean, unless you include underscore birth date or unless you do something very specific, there's no guarantee that you'll even know that there's a modifier extension on it. And that's kind of dangerous because, you know, if you have an extension that says, I'm trying to think, well, an allergy extension that has a modifier or a diagnosis that has a modifier that says family history of or something, you shouldn't be able to retrieve the unmodified fact without retrieving the modified fact. And so that is the dilemma here is how do we correctly include modifier extensions so that it's difficult or impossible to get the basic fact without including the modifier, and at the same time make it easy to get non-modified extensions.
Yeah. Now, let me just clarify, though, that the issue of modifier extensions, I think we broke that into a separate issue because that's,
Right.
But the basic issue is really what to do about this extra blank node that we introduced in R4. Should we get rid of it? And if we do get rid of it, how should we get rid of it? And I think we collected a few ideas for possible ways to get rid of it. And here is one of these ways, which is
David,
basic.
I have a basic question regarding
Yeah.
that. Are these data type properties or object properties that
That's the point. Yeah, that's a great question, and that's exactly the point that one would normally want to consider this to be a data type property, not an object type property.
But it is an object property here.
But we made it an object property for R4 specifically so that we could enable it to be extensible.
Okay,
Yeah.
so if it is an object property, I mean,
But we want it to be a
answered
data
my-
type property.
Well, you answered my first question, right? One is
Okay.
if it is for the first thing is like, is it a data type or an object property? If it is a data type, it needs to be a value, right? There's no argument there. But since the choice to make this an object property was made, I'm curious about why, why the introduction of a blank node, a little bit of indirection there makes an issue. It becomes an issue because it seems like it needs to be consistent. As long as it is consistent across all the, object properties, that's how you represent them. It should still be okay, right? Once the problem comes when you do it one way sometimes and the other way sometimes, right? The example was with the gender and versus the birth date. With the gender, it seemed like it was a direct representation, whereas with some
it wasn't.
It was okay. I'm sorry.
Yeah.
But
so
either way, right? Having a blank node in Sparkle should actually be fairly easy to deal with, right? You don't even actually have to deal with it, as long as you can make that connection in the where clause.
Well, I mean, that's what we sort of thought when we first designed it,
Mhm.
but it's turned out in practice that when you actually try to use it, it's just more cumbersome that way. You've got that extra thing you've got to go through, in order to get at what you want. So that's really the issue. It's purely a practical consideration, right? It's not a theoretical consideration at all.
Yeah. But it seems like it's, as long as you're consistent with that, it seems like it's just one additional pattern match, right? That you need to include. And
it is, you're right. It is just one additional pattern match, but you end up having to do it over and over and over again. And it gets unpleasant.
I agree with you. That's been the bane of a lot of things, but it's
the challenge isn't just in the data itself, which you're absolutely correct. I mean, once you figure this out in the data itself, it isn't bad. But now, what if I ask you, what's the data type of patient birth date? And there is actually an established data type, but now if we want to go query the FHIR.ttl, the description of our RDF, to find the data type of patient birth date, it's an interesting question whether we can even get it there, because we can't, because we happen to know that it has a FHIR value inside that's type XSD date, but there's no sensible way to document this that I'm aware of in the RDF, because at the moment, birth date is an object property. It doesn't have a data type, and there's only one FHIR value out there, and it can assume any data type on the planet.
No, this is a very silly question, but I mean, you can always, for things which are as specific as gender and birth date, you can always specify a range, right? Like the range value to be as a birth date class, or a gender class, or a subclass of that, right? You could always do that.
Yeah, there's ways to fix it. And I guess that is the question right now, is before we charge in too much further, does it need to be fixed? Is it in fact broken?
Right. So certainly one option is to leave it the way it is. But the general feeling that Harold had and expressed, I think, pretty well, was that we made the classic design mistake of making the unusual case easy to do, and the common case cumbersome or difficult to do. You know, when we should have done it the opposite. Because having an extension on a data type property, or on a literal kind of property, not literal, but data type property. That's not common. It's not common to want to extend something. This is an example from the FHIR spec, but it's, there really aren't very many of these things that you're going to want to extend. Like Boolean, for example. Who's going to want to extend Boolean? I mean, maybe somebody would want to extend it by adding a probability or something, but that's really rare.
I mean, it seems like when we do this kind of a thing, right, it seems like we are misusing the intent of what these things were supposed to be, right? If it is supposed to be a primitive data type, birth date is supposed to be a primitive, keep it a primitive, and create a new one. Similar to how Java did it, right? They have the primitive int, float, and all that, but then when they changed, they realized that's not enough. They created the big int,
right,
big Boolean, big B Boolean, and all that, right? Big I int and all that stuff, which they both map to each other. It's in magical ways, right? So when you ask either one, you get the primitive value if you need to. So it's, I mean, by trying to use the same one here, which seems to indicate that it's a data type property, and you're expecting a primitive value, but then you return an object or thing, then it will lead to some confusion, actually a great deal of confusion.
Yeah, exactly. So that's what we're trying to, that's what we're contemplating, changing. And so among the ideas that came up, one idea was to, you'll notice that in the, where's the JSON? Okay, in the JSON, you'll notice that in the JSON, they got this convention of putting an underscore in front of the extension one. And so one idea is to actually map this one with the extension to be the same property as this one, so that it's kind of like an ambiguous thing where that single property then can hold two different things. So here's the example. So this would be done in JSON LD context using this kind of syntax here. But the end result is that something like this in JSON, where you've got both of those, would be mapped to a single. Oh,
Yeah.
sorry.
What you can
Here we
do
go.
there, David, if you just go back to the one up above.
Oh, sorry.
Okay, in RDF, wherever you are, in RDF,
Yeah.
there's nothing that requires the underscore there. Because if you just remove in JSON, it's an error if you remove that underscore because it's a unique tag. But in RDF, what it amounts to is that birth date has two
values.
Two values. One is the good old date, and the second then is, if needs be, the B node
object.
that includes the extension.
Yeah.
So
if we look at the RDF, the resulting RDF, then I've got to make my screen bigger here. Oops. I think it's this one. Yeah, that's one. Is this visible here? So here, there's the date time.
So David, while you're going through this, I have something that I need to ask. So the first line of this, right, and this seems to be happening both in the JSON LD and
There
this example. The first line, right, you have the birth date at
there's the birth date.
Yeah, at a date level precision. And then about 7 or 8 lines below that, right, you have in the extension part, value date time.
Right. So here's the second value is the B node that then has the rest of this structure.
Yeah. So if you're in the middle of what you just highlighted, you have extension.value date time, you have a time element there which says 14:35:45. You've added extra precision there. Is that an intentional thing or an unintentional thing?
Yeah, that was the purpose of this example of this extension, is to add more precision to when the person was born, not just giving the day, but also the time when the person was born.
But you could do that right at the top, right? In the first one.
Well, no, because the data type for this one is just a date in JSON at least.
Yeah. So you're correct on that particular example, but anything, I mean, extensions can do all sorts of things. So you, instead of, I mean, this example says add more precision, and your argument that, well, we can just add more precision to the base type is technically correct, although the FHIR spec says you can't. But you can also have an extension that says, source. A reference to who said that was their birth date, or you can have an extension that says certainty and a value that says we know the year is correct. I mean, what goes in the extension is up to the extension writer, and in this case, the extension example could be arguably put into the base type, but in general, that's not the case. It's added information that isn't covered in the FHIR spec or in the base FHIR spec. FHIR extensions are exactly what tell you what the extensions mean.
Jim, you got a hand up.
I've got a question about this. I can't remember, do you mean for this RDF to be usable as OWL? I think you had an OWL ontology that import to do that.
Yes.
Okay, because relating to that, there's a problem with using the same property name, because you can't be an object property and a data type property at the same time.
That's exactly right. I wonder if that, no, you're absolutely right. I should have listed that as one of the cons here.
Okay.
Yeah, that's, you're absolutely right. On that, Jim, is that, that the problem is that in a sense, we're punning to make that work. got
But yeah, unfortunately, you can't pun
properties.
different
Right.
properties.
So another option on this, and I don't know whether we listed it here, but when I look at it, it becomes pretty obvious, is since we're already composing predicates based on path structures, we could simply define a second property, which is birthday dot extension. So that there, again, we're sort of coming back to lexically related properties.
Yeah, it's the same idea as doing an underscore.
So instead of, so it's foo and then foo dot extension would be a way of separating the two. And the nice thing is that if you play in the extension world, you know that you need to run a query with both of those predicates. If you don't play in the extension world, which most people don't, you don't have to worry about it. It would be fascinating to see in the code that's written against the JSON today, how often there's anybody has code for the underscore type.
Right. Yeah. I don't have any data on that.
Yeah, it'd be curious to see who does that.
Okay. So yeah, and so just want to point out, Harold, that's equivalent to using the underscore conventions, just like different characters of having it built syntactically into the name.
Yeah, exactly. Well, it seems, I'm not positive whether you'd be able to establish formally in an ontology the relationship between birth date and birth date dot extension. But since you have both predicates, one is a data property and one is an object property, there might be some way to glue them together, but I don't.
Well, I think that maybe one of the other options, yeah, here, it's this option here, option 3, in essence. This one
Right.
is talking about underscore, but it's the exact same thing for if we did it using the word dot extension.
Yeah.
And so that would, that could use an ontology relationship to connect those properties together to indicate that, one is an extension property for the other one.
Can you explain that? I'm not sure I follow what it means, what you're saying here. When it says ontology relationships to connect attributes.
Yeah, so for example, you would say something like FHIR : birth date. I'm making this up on the fly.
Always the best.
FHIR has extension property FHIR : underscore birth date, like that. Does that make sense? So that means in the data.
Hang on,
Yeah.
David. So FHIR FHIR birth date, that's a property?
Yep, that's a property. Yeah.
So property has a relationship. So currently, I think OWL doesn't let you create relationships on properties, right?
Well, you're able to do sub-properties.
Yeah. So is this
This would be like punning the property as an individual one, but
yeah,
the meaning is in your own interpretation. It doesn't like have an OWL.
Yeah, it does. You're right. It doesn't. I don't know of any OWL way to express this.
Yeah.
It's certainly allowed in RDF.
Yes.
It's a relationship between two property names. Yeah, two properties. And then you could then use it in Sparkle queries, for example.
Yeah, and one of the things to think about here in the RDF world is the FHIR rule is basically unless like here I've got an extension where the extension is certainty that's defined somewhere. Unless you know the definition of this certainty extension, you're not going to be using this stuff anyway. So in RDF, as we interpret FHIR extension definitions, subsets of FHIR profiles, we should be able to extend the ontology so that if you import the Boolean certainty extension into your ontology, you should get the definition of that particular URL, which is arguably the predicate. I mean, one way to look at this is that the subject is, what's an interesting question of whether it's what the active applies to or the active itself. But the extension says that this assertion has a certainty of 0.75.
And then using that relationship between the properties, you could use that in Sparkle, for example. Here's an example of how you might use it in Sparkle. But
so you can actually do this. I didn't realize you could do that.
Well, this would be certain. Yeah, this would all be definitely legal RDF.
But the semantics of FHIR extension property are entirely our definition. However, I mean, there's nothing in any OWL reasoner that understands that, or arguably even could understand that.
Right.
Yeah. So why not make it a subproperty then? If that's
because a subproperty, because of the clash that you mentioned earlier about that it can't be both a data type property and an object type property.
Yeah,
so,
that's the problem is it's split right at the root there. An object property can't turn into a data property.
So, David, I don't know. Somehow this feels like an over-engineered kind of a solution. I'm wondering.
I hear you.
Like jumping through hoops to accommodate.
No, I know what you mean. Yep.
Yeah. So what would be the disadvantage of doing this is a simple pattern, because if you go back and if you create everything as an object property, but then it for many of these, it always has a value property associated with it, as well as an enriched, another property called enriched within it. Then you're dealing with two things, right? So anytime you want to have a data type aspect of it, you ask the value for it and you get it. Anytime there is an enriched property, or I just made that up on the fly, but that property, you get a very rich data structure now that tells you whether it is in the gender, or it is with birth date or address, or it doesn't matter what it is, but it gives you this rich data in a very consistent manner. So at any time, anybody who's querying, they only need to look at two things: either a value property or an extension or enriched or something like that. And that should make querying much easier and make it more consistent. You actually have that there. Yeah. Similar to that.
Well, that was exactly the philosophy that we took when we designed R4. And so what we did in R4 is exactly what you just described. We chose the word extension instead of enriched, but same idea.
So what is wrong with that? Because
what's wrong was when people actually used it in practice, they discovered that this is kind of a pain in the butt to be having to do this indirection every time I want to get a data type a property like a birth date. I've got to go through that extra level of indirection of asking for the FHIR value of it instead of just getting it directly.
So, I mean, to summarize, okay, there's the query point, which is whenever you hit a terminal node, you have to understand in FHIR the difference between data types and data properties and object properties anyway. Because a data property is going to have an inner value while an object property doesn't. So birth date is going to behave radically different then patient status, which is a coded element. And then the other thing is that the second is the complexity of what is the data type of birth date. Well, it doesn't have a data type, it's an object property. So getting the declarations. And then the third is just to the outside user. I mean, a simple query that it turns out that the FHIR patient resource includes an attribute called active. And that's a meta property. It doesn't say anything about whether the patient moves around. It tells you whether the record you're looking at is current or not. So pragmatically, anytime you want to query a triple store that includes patient records, you probably want to have a where patient.active is true. But you can't include where patient.active is true. You have to include where patient.active contains a FHIR value that is true, and just getting that into the queries and explaining that to outside of FHIR communities is a challenge, but it may not be worth the cost of changing it. And so that's
I would challenge that assumption, Harold, because I think most people coming into healthcare data for out from outside the healthcare perspective, I think they underestimate the complexity of the data and what we have to deal with. So, for example, just taking the value, right, birth date, right? That's a simple thing. It's as simple as it can get. You have a birth, date, time, and all that. Now, you take anything which is at the next level, which people still think as a data type property with a simple value, like let's say height information or weight information. Right now, you have a value and a measurement unit. Now, in RDF, in a lot of the other ontology work that I've done, we've moved away from using it as a simple value to declaring it as a measurement value, a datum, so that it has two things in it, right? When you ask for the value of height, you get a measurement datum, which has two parts to it, which has a value and the unit associated with it. So it's already become a more complex thing when you're talking about anything more than a simple string or a date and things like that. So I think it is the nature of the data that we represent it as accurately as we can, and as long as we are consistent with how we are doing that, right? Like for measurement, all measurement datums, we always provide that value and the data and the unit associated with it. It becomes easier for consumers of that data to use it. It's just mechanics at that point. But so trying to make this simple so that we can just make it, it seems like, I'm not sure it's in the right direction.
Yeah, well, yeah, it might not be. Right. This is what we have to assess.
Is there any place we could get more information on that? I mean, that's certainly a valid assertion, and if there's any sort of consensus on it, then it makes our job a lot easier because we don't have to change the spec. I mean, in one sense, it makes our job easier. It also means that we have to do the structural transformations because the JSON doesn't look like the FHIR. So I mean, like the RDF. So we've got some more explanation to do because why doesn't this look like the JSON? But how do we? Where else could we go to find out? I mean, what I'd be interested in is are there communities that are using FHIR and happy with it, FHIR RDF and are happy with it? The harder one is are there communities that decided not to use it because it was too hard and would have used it? And I don't have an answer and I don't know how to get it.
Right. I think that would be the main thing that we would want to get is people's experience actually using it. is hearing from as many people as we can who have used the FHIR R4 as that is currently in place to give us their feedback and say, how has this worked out for you? So
Yeah, I
that's,
mean, so, I'm one of those people, and I would say that even though I made the comment earlier that it was a little painful to figure out how to query it because of the issue that we've been discussing, I sort of agree that over-engineering it to correct the issue almost doesn't seem worth it to me, because once you're used to it, then that's just part of how you use it. I guess maybe it just seems like there's bigger fish to fry. That's all.
It's interesting you use the term over-engineering, because had we not done this to begin with, had we just done the translation literally, we would be calling this over-engineering.
Well, so
Yes.
maybe once it's over-engineered, then engineering it again is over-engineering.
Yeah. So re-engineering.
Re-engineering the over-engineering, yeah.
Because that would, if it can be asserted that the FHIR RDF as it exists is useful, and we're not going to be chasing people away, then that takes just one task off of our to-do list, which is nice. We don't have to go further.
do we have, who else on the call has made use of FHIR RDF and can give us their feedback on this?
I haven't used it in anger or as in production, but I'm creating this RDF based electronic health record, FHIR RDF based electronic health record, so I put some points in the chat, but it's basically the same thing. I mean, it would be nice to know where the blank notes are, because in some cases there's blank notes and there is nested blank notes. If there is a way we can, I can look that up. I mean, I've always found it quite easy to use if there is some sort of a graph-based visualization, and this is RDF in general. And if there is a blank node that has some sort of an identifier, and then there are edges and nodes going out of that, it might be a bit easier to explain the concept to non-RDF people, or even for RDF people, just to understand how this is structured. So that's just my experience. I mean, the blank nodes, okay, if it's a set pattern that's repeating everywhere, you just train yourself to look for it. So, I mean, initially it was a bit confusing, but I just got used to curing for a blank node. But it'd be nice to know where the blank nodes are, because right now the only source that I have is the examples, the turtle examples.
Yeah, they tend to show up, I think, in any of the data type properties, or any of what you would normally consider data, what you would normally assume would be data type properties.
Okay.
Thank you.
And
But
I would argue that the number of data type extensions are diminishingly small. And another interesting thing that might be worth looking at is, while there are contrived examples like the one we're looking at here of data type extensions, it would be an interesting question to discover how many data type extensions, if any, are used in real FHIR specifications in anger.
Harold, I regrettably was trying to catch up on the chat, which I hadn't noticed before, and so I didn't get all of what you said. Could you say that last bit again?
Okay, the question I've got is that while FHIR certainly allows data type extensions, and in their examples show how it might be done, how many specifications today, how many profiles actually extend data types? Does anybody actually do this? Because another, we'll call it the reverse of over-engineered another under-engineered solution is to say, well, we just flat don't support extensions in RDF, or if we do, we support them just like the JSON does, and it's up to you to remember you have to put an underscore and have at it. If nobody uses it, it's a double pain to have to learn how to do this just to deal with something that nobody's ever even done in real life.
I'm wondering if part of the confusion arises from the use of the word data type property, as we use it in OWL RDF. There is a clear distinction between data type and object properties.
Right.
Now, other languages don't seem to make that distinction. So in, you can have Sivaram, by the way, David.
Oh, sorry, yeah.
SIVA. Sorry.
Yep, sorry about that.
No worries. So
Yes, sorry. Yep.
most languages don't seem to make that distinction, or at least I don't know of any. I don't know of it where you can have a data. I mean, everything is called a data type property, right? So so I think maybe we should. This is an opportunity to distinguish them, or if you don't want to, then maybe create everything as an object property and go that way.
Well, that's what we're doing here. That's what we do.
That's what we're currently doing, yeah.
Yeah. FHIR, by the way, does make a distinction internally between data types as we know them, which in modeling languages are defined as things whose values are their identities, numbers, strings, dates, and that sort of stuff. And what they call compound data types, which are structures that the key things being that they still lack identity. But anyway.
Yep, that makes sense.
Mm-hmm.
Okay, we're out of time, so we didn't get through all of the options that we've come up with so far for possible solutions to this. And I guess obviously another possible solution is to not do anything, to leave it the way it is. So that, I suppose, should be listed as an explicit option. We didn't list it here. But that at least gives you an introduction to that issue. Is there anything else that anybody wants to comment or say or add or suggest before we close for today?
So David, I don't know if you remember this thing about there's the truthful data, and then there's the inferred data stuff that we were doing before at the Cleveland Clinic thing, where I'm wondering if we can use a similar kind of approach in this, where you have the main properties that you're specifying here are the object properties, but then you have an extended set of properties, right? Data type or shortcut properties that provide you similar kind of a thing. So for example, you have this birth date as the primary source of data, you still have an object property there, but you have an extended one, like maybe you're calling it birth date value, right? And that gives you the birth date straight away. But that's always like an enrichment on top of that pulls out just that value aspect and gives you a direct connection to it, right? It's providing a shortcut way to the value part of it. That mirrors the object property. Now, I don't know if that is something that you've looked at or considered here.
So how would the shortcut property be expressed? How would it be written?
It's because it's a graph, right? It's another relationship.
Oh, an additional property.
Yeah. So it's a shadow property kind of a thing, which mirrors
shadow
the
property.
object property, right? So it's
Okay.
it's by saying you have a birth date object property, which has this rich data structure with it. But then if it has a shadow or a property there which says, birth date value, and you just get you're able to get the value part of it.
I like,
So would that be
that's a great idea.
conceptual? Wouldn't that be conceptually similar to this one here? If I'm understanding you, you're saying to have two properties, one gives the whole object.
Yeah.
And the other property is like a shortcut to just the value.
That's it.
So that's,
It's
I
not
like
something-
that. I like that a lot, because what you can do then is, so in that case, instead of active true, let's arbitrarily say it's fire.active.value true. So we do exactly what we do today. We don't change anything. We just, for every primitive data type property, at bare minimum, we toss in one more, which is fire.active.value, fire.birthdate.value, fire.whatever, which is, as he calls it, the shadow property, so that you can get at it either way. And we could, to generalize, even on complex embedded properties, we could simply we could add a value that resolves to exactly the same thing as the non-value if we needed to be consistent. I like that idea.
okay, so if I've got this, if I've understood correctly, the basic idea is to have two properties, one of which would go
Scroll down a
directly
bit.
to the
Scroll down
value.
a bit further, David, because we're in the RDF. Oops, up, now back up. The RDF is what we're looking at here. Okay, right,
Yeah.
two properties.
So the idea is to have one that goes directly to the value like this, similar to this.
Value, yeah.
Yep. And then a second one, this one, in this case, it's called underscore active, but we could call it something different. A second one would go to an object, but instead of that object only containing the extension, that object could actually contain both the original FHIR value true and the extension. Is that the idea?
Well, what
Kind
I'm
of a hybrid.
hearing, I'd word it a little differently. If we go back to the original way that we're doing extensions today, do you have?
Yeah,
one on
it would
this?
be done that way. Yeah.
Well, so go back to wherever we've got
Okay.
the way it works today.
All right. Let's see. Is that
Is
in?
that.
That's not in this one. That's in. Sorry, I got to find my correct tab for it.
Thanks for that. Okay, right, here we go. This
Is that the one or not?
Yeah, this
No,
is a
no,
good
no. That's
actually,
not.
actually, that's a good example.
Right.
That was a good example to actually look at, I think.
But let's take this one here. Okay, so this is where we exist today. So
Yeah, that's right.
one approach to it would be to add one more triple, which is fire.patient.birthdate.example.value,
Yeah.
fire.birthdate.example 1974.
Mhm.
So we have all of that. This doesn't change. You've just got one more, which is the value shadowed or whatever the term is.
Right.
I like that. I think
I'm going
that,
to add this as another option. Where am I?
I mean, the nice thing is that doesn't break what exists, so we don't hurt anybody. And it's an incremental change on the sort of work we've done to date. It's additive rather than a change. Good idea.
And one of the things is, do we have optional and required kinds of things in here? Because if you do, the idea behind this is that you would have the rich object, right? The rich data structure be the required field, and the shadow property, which is the shortcut one, be the one which is optional and is always generated from the richer data structure and is a read-only value. It cannot be updated directly. It has to be updated only by the system which is creating that the object in the first place. Right. So there is.
Do I have this right? So
Yeah.
here's your shadow property here. Yep. And this is the way it has been done in R4.
So I'm not sure
would
I understand the dot value part of it, but because it's
It's just to give it a different name.
Yeah.
Yeah.
We could instead call it underscore birth date.
I mean, I was wondering if
No,
it
not
needs to be
underscore
at this-
birth date. We wouldn't want to do
Yeah.
that. Sorry, that would be confusing the wrong way.
Yeah, that'd be really lousy.
We could call this one birth date, and we could call this one underscore birth date if we wanted.
So the dot
but-
notation here, David, does that include a path, or is this one property?
No, that's just a property name. So I can change it if you want. I'll make it value.
And by the way, the
Okay.
dot notation is another issue in that, strictly speaking, dots and URIs are considered really bad practice.
Yeah, that's the reason why I was wondering, right? You know, if you want to keep this FHIR patient underscore birth date value, or birth date underscore value, or whatever, whichever way you want to do.
Okay, I'm going to
Okay, so
break off in a minute here, David.
yeah, we're over time. So
I think that's
trying to capture this. That's
No, actually, if you keep it that way, you know, keep it go.
well, I'm
back.
putting both
Yeah.
both ways.
Ah, okay.
Yeah.
Now, so what this does, David, is it seems to make the birth date as the primary, whereas the extension one is the optional. So what I
Mhm.
suggested
Yep.
was the other way around. Make
Yep,
the
it
birth
was this
date
way.
extension one as the primary, and
Yeah.
the birth date value as the one that is, hey, if we're lucky, we can have a
Yeah.
you know a
Right.
direct path to that.
The
Yeah.
disadvantage of the other way around, which is probably pretty minor, is that it breaks existing code if there is existing code.
Yeah. So here's two variations, A4A and 4B. Okay, very good. So we're out of time here. I'll try to clean this up a little bit. But thank you all very much. I think we're going to have to adjourn at this point.
Thank you, David.
Thanks all.
Right.